Once again, a very good morning to all of you. Today, we shall discuss the new topic and a new chapter, continuity and differentiability. Continuity means, in this topic, we shall connect the topic of class 11 limit with this topic. Continuity means, in the topic continuity, we shall connect the topic of limit with this topic. So in class 11 we have already discussed the limit of a function will exist if limit x is tending to a plus fx equal to limit x is tending to a minus fx equal to L if means left hand limit of the function and the right hand limit of the function, if both are exist and equal, then the limit of function will exist, otherwise it is not exist. If any one of them is not exist, then the limit of function will not exist. This is the concept of the limit. But here we have to discuss the concept continuity. Continuity of a function at any point. Before discussing the continuity, first I would like to discuss two examples. One by one we discuss. Example 1 is that fx is a function whose value is 1 and whose value is 2. X is less than equal to 0 and x greater than 0. From that function we can easily find that the graph, first we will draw the graph of this function. The graph of this function is that x is less than equal to 0 means this is negative, this is positive side of x-axis, and this value is 1 and this value is 2. So if x is less than 0 equal to 0, so this is 0. -1 to -1, -2 to -2. It means this is the graph of x less than equal to 0. If x is greater than 0, so value is 2. It means from this result we can, from the graph of this function, we can easily find that this portion is of this part of the graph, this part of the function, and this graph is this part of the function. It means in this graph we cannot draw a graph of function in one stroke. It means, suppose if we draw this function up to this point, then we have to lift the pen from the board, or we have to lift the head from the board, and we will draw that function. Means without lifting the pen from the paper, we cannot draw the graph of that function. So it means this function is not continuous. Continuity means if we are able to draw the graph of any function without lifting the pen from the paper, that function is called the continuous function. So why we cannot draw the graph of this function without lifting the pen from the paper? So it means the left hand first, at which point this function is broken. हमको सबसे पहले ये चेक करना है किस पॉइंट पर ये फंक्शन ब्रेक हो रहा है, ब्रोकन है. इट इज ब्रोकन एट 0. आप देख सकते हैं 0 पर हम यहां से यहां तक आए, उसके बाद हमको पेन को उठाना ही होगा, तब हम आगे का ग्राफ ड्रॉ कर पाएंगे, क्योंकि ये लाइन इस एक्सिस को टच नहीं कर रही है, पाई एक्सिस को. सो यहां पर चेक कर सकते हैं, यहां पर हम बिना पेन को उठाए ड्रॉ कर सकते हैं, यहां पर भी कर सकते हैं, लेकिन किस पॉइंट पर एट x इक्वल टू 0 we cannot draw the graph of function without lifting the pen from the paper. So why this? Why we cannot draw the graph of this function without lifting the pen? So if at x equal to 0, we will check at x equal to 0, the left hand limit of the function 0 plus fx equal to 0 plus means right hand limit of the function 0 plus means 0 से ज़्यादा greater than 0. The value of function limit x is tending to 0 plus this is 2, so this value limit x is tending to 0 minus fx. It means limit x is tending to 0 minus fx is 1, so this value is 1. And at x equal to 0, the value of function is also 1. We can easily see the limiting value of the function not equal to the exact value of the function. It means at x equal to 0, at x equal to 0, limit x is tending to 0 plus fx, limit x is tending to 0 minus fx, and f0. This is 2, this is 1, this is 1. It means they are not equal. If they are not equal, so due to which we cannot draw the graph of that function without lifting the pen from the paper. So due to this problem, this function is discontinuous, not continuous. This function is not continuous at x equal to 0. This is discontinuous function at x equal to 0. Now we will consider another example. Suppose example number 2. Fx equal to 1 and 2, x not equal to 0, x equal to 0. We will change the conditions of the function. First we shall draw the graph of this function and check whether this is continuous or not continuous. This is x, x dash, y and y dash. This is not the continuous or discontinuous. We will check why drawn the graph of this function. So at x equal to not equal to 0, this is 0. Suppose x equal to 1, so value of function is 1, 2, 2, 3, 3, minus 1, minus 1, minus 2, minus 2. इसका मतलब ये हुआ कि ये फंक्शन जो हम खींचेंगे 0 पर इसको यहाँ पर टच नहीं करेगा और 0 पर टच नहीं करेगा. सो वी विल टेक द ओपन सर्किल. ओपन सर्किल लेंगे हम इसको कनेक्ट किया. दिस इज द ग्राफ ऑफ फंक्शन एट x इक्वल टू when x not equal to 0. If x equal to 0, the value of function is 2. At x equal to 0, the value of function is 2. This is the 1 and this is the 2. So in this question also, we cannot draw the graph of function without lifting the pen. आप देख सकते हैं यहाँ ड्रॉ करेंगे, लेकिन इस पॉइंट पर हम पहुंचने में पेन को हमको उठाना होगा, फिर यहाँ पे आएंगे, उसके बाद फिर यहाँ से फिर ड्रॉ करेंगे. So why we will get this condition? It means something is wrong. What is wrong? We will find at this point at x equal to 0. At x equal to 0, we will check the left hand limit, the right hand limit, and value of function that point. So at x equal to 0 plus fx equal to limit x is tending to 0 plus fx is value of function. This is 0 plus and this is 0 minus. So this is 1. Similar, limit x is tending to 0 minus fx equal to limit x is tending to 0 minus. This is also 1. so this is 1, and value of function at x equal to 0, this is 2. यहां पर भी चेक कर सकते हैं, यहां पर क्या हो गया, फंक्शन की लिमिट तो एग्जिस्ट कर रही है लेकिन लिमिटिंग वैल्यू नॉट इक्वल टू एग्जैक्ट वैल्यू. इट मींस लिमिट x is tending to 0 plus fx equal to limit x is tending to 0 minus fx equal to f0. तो यहां पर आप चेक कर सकते हो, ये तो इक्वल है, ये भी है, लेकिन ये इक्वल नहीं है. 1 1 not equal to. So due to this function is discontinuous. चलो हम एक एग्जांपल ऐसा लेते हैं जिसमें फंक्शन हमारा कंटिन्यूअस हो. हम दूसरा एग्जांपल ले रहे हैं, एग्जांपल 3 ले लेंगे. यहाँ पर फर्स्ट वी शैल टेक एग्जांपल at x equal to 1 fx equal to 2x plus 1. We know that this is a polynomial or in first degree, so the graph of this function always a straight line, or we can draw a straight line without lifting the pen. So what is the position of this graph? What is the graph of this, or y equal to 2x plus 1 0, x equal to 0 पे y 1 मिल जाएगा हमको, x equal to 1 पे y 3 मिल जाएगा हमको यहाँ कहीं, और y equal to 0 minus 1 by 2 पर यहाँ कहीं इसको इंटरसेक्ट करेगा. It means we can draw the graph of this function without lifting the pen from the paper. So this is continuous. How it is possible? ये क्यों continuous है? हमने ठीक है ग्राफ से देख लिया कि हम इसको पेन को बिना उठाए पेपर से पूरा ग्राफ ड्रॉ कर सकते हैं. But mathematically we have to check these three conditions. Mathematically limit x tending to 1, इस पॉइंट 1 पे चेक करना है, 0 भी कर सकते हैं, 1 पे भी कर सकते हैं, किसी पे भी कर सकते हैं. 1 plus fx, so this is x is tending to 1 plus function is 2x plus 1. By putting the limit, this value is 3. So this is either right hand limit or left hand limit. This is RHL, this is LHL. So fx limit x is tending to 1 minus fx is again 2x plus 1. So this value by putting the limit is 3, and value of function at x equal to 1 also 3. This. It means the limiting value equal to the exact value of the function at that point must be equal. The function is continuous at that point. तो यहाँ पर हमको क्या डेफिनेशन मिली? A function, a real valued function is said to be continuous at x equal to a, any point a, if the limiting value at a must be equal to the exact value at that point, so the function is continuous at that point. Now from the above example it is clear that from this example it is clear that since limiting value f1 plus f1 minus fx equal to f1, all are equal. Left hand limit, right hand limit and value of function at that point must be equal. अगर ये तीनों इक्वल हैं तो ही फंक्शन उस पॉइंट पर कंटिन्यूअस होगा, अदरवाइज फंक्शन उस पॉइंट पर कैसा हो जाएगा? डिसकंटिन्यूअस हो जाएगा. डिसकंटिन्यूअस का मतलब आपको मैं 2 एग्जांपल में बता चुका हूं. फंक्शन किसी न किसी पॉइंट पर ब्रेक हो जाएगा, पर्टिकुलर जिस पॉइंट पे चेक कर रहे हो उस पर ब्रेक हो जाएगा और उस पॉइंट पर फंक्शन कैसा हो जाएगा? डिसकंटिन्यूअस हो जाएगा. सो व्हाट इज द डेफिनेशन ऑफ द फंक्शन? डेफिनेशन ऑफ of continuity of a function at any point, a function, a real value function f is said to be continuous at x equal to a. इस फंक्शन को हम कंटिन्यूस बोलेंगे किस पॉइंट पर, a पॉइंट पर, if limit x is tending to a plus fx equal to limit x is tending to a minus fx equal to fa, or we can say limit x is tending to a, because this consists left and right both limits equal to fa, then function is continuous at x equal to a. मतलब अगर किसी फंक्शन की लिमिटिंग वैल्यू और एग्जैक्ट वैल्यू इक्वल है तो वो फंक्शन उस पॉइंट पर कैसा होगा, कंटिन्यूअस होगा. दिस इज द डेफिनेशन. नाउ वी हैव टू डिस्कस one example related to this definition. We shall discuss the continuity of the function discuss the continuity of function, discuss the continuity of function fx equal to mod of x at x equal to 0. All of you know very well the graph of modulus function. In class 11 we have already discussed the graph of modulus function. The graph of modulus function is just like this and this. आपने देखा होगा मैंने बिना पेन को उठाए, बिना चार्ट को बोर्ड से उठाकर पूरे फंक्शन का ग्राफ ड्रॉ कर दिया. इसका मतलब अब आप समझ ही गए होंगे कि ये फंक्शन कैसा है, कंटिन्यूअस है, हर पॉइंट पे कंटिन्यूअस है. बट वी हैव टू चेक द कंटिन्यूटी ऑफ दिस फंक्शन एट x इक्वल टू, मींस एट दिस पॉइंट वी हैव टू चेक द कंटिन्यूटी. सो by using that method to check the continuity of any function, so at x equal to 0, at x equal to 0, RH. First we shall discuss what is the value of modulus function. Modulus function, mod x equal to x or minus x, x greater than 0, x लेस देन 0. ये हम आपको क्लास 11 में डिस्कस कर चुके हैं. फिर भी मैंने आपको एक बार बता दिया, mod x is equal to x and mod x equal to minus x. So limit x is tending to 0 plus fx equal to limit x is tending to 0 plus fx means mod x, and value because this is 0 plus means 0 से ज्यादा, और जब x 0 से ज्यादा होगा तो mod x के लिए क्या लिख सकते हो, इसकी जगह आप x लिख सकते हो, और इसकी जब वैल्यू रखोगे तो ये क्या हो जाएगा 0. सिमिलर वी कैन फाइंड द लेफ्ट हैंड लिमिट ऑफ दिस फंक्शन बाय यूजिंग दैट लेफ्ट हैंड लिमिट फॉर्मूला. लिमिट ऑफ दैट फंक्शन x टेंडिंग टू 0 minus fx, limit x is tending to 0 minus fx means function value of function is mod x, but here the value of x 0 minus means less than 0, so modulus of that function is minus x. Limit x is tending to 0 minus, this is minus x. If you will put the limit of that function, so you will get the 0. Again the value of that function at x equal to 0, so this is also 0. Left hand limit, right hand limit, left hand limit, and value of function all are equal. It means this function is continuous at x equal to 0. Or we can say the modulus function is continuous at x equal to 0 always. Or we can say the modulus function is continuous at every point of its domain. Because not only 0, we can also check the continuity of that function. Suppose this is the point 1. We can check the continuity of the function at x equal to 1. 1 पे भी आप देख रहे हैं 1 के पहले और 1 के बाद में फंक्शन कहीं ब्रेक नहीं हो रहा. जो ब्रेक नहीं हो रहा, इट मीन्स फंक्शन इज कंटिन्यूअस at x equal to 1. Or we can check through this formula also by taking this is 1, this is 1 plus mod x. 1 plus means always x, so this value is 1. 1 minus means also 1, that is 1, and value of function f1 is also 1. So on that case, at x equal to 1, the left hand limit, the right hand limit, and the value of function is all 1. So this function is also continuous at x equal to 1. Is that clear? Similar, we can say a function is continuous in a closed rate interval AB if it is continuous at every point of that closed interval, then function is said to be continuous at that interval or in that interval. कोई भी फंक्शन किसी क्लोज इंटरवल में अगर कंटिन्यूअस है, इसका मतलब वो उस क्लोज इंटरवल के हर पॉइंट पर कैसा होगा, कंटिन्यूअस होगा. सिमिलर, वी हैव टू डिस्कस one more example. Example is that every polynomial function is continuous. Polynomial function, all of you know that very well. What are the polynomial function? Polynomial function is continuous, always continuous. Polynomial function is always continuous. Example, every polynomial function is continuous. Suppose we are taking a polynomial px or fx, no problem. a0 plus a1x plus a2x square plus an x e power. This is a polynomial of degree n where an not equal to g. This is the polynomial function and we have to check. Suppose we are taking any point, point is c. We have to check the continuity of that function at x equal to c. So at x equal to c, we will check its right hand limit. For c plus or c minus, the function is same. So we will put the limit of that function at x equal to c. We will get the value a1c plus a2c square plus dot 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 a(n)(cn). Similar, we can find the left hand limit of the function at x equal to c. So this is c minus after putting the limit, we will get a0 plus a1c plus a2c square an(c) power. Similar, at x equal to c, the value of function fc is also a0 plus a1c plus a2c square an(c) power. इसका मतलब ये हो गया कि लेफ्ट हैंड लिमिट ऑफ द फंक्शन एट सी, राइट हैंड लिमिट ऑफ द फंक्शन सी एंड एट एक्स इक्वल टू सी. सी यानी आर्बिट्रेरी पॉइंट. इसका मतलब हर पॉइंट पे पॉलिनोमियल फंक्शन कैसा होता है, कंटिन्यूअस होता है। तो अब अगर हमको कोई भी क्वेश्चन मिलता है और उस फंक्शन में अगर वो पॉलिनोमियल है तो हम सिंपली लिख सकते हैं बाय द हेल्प ऑफ थ्योरम, बाय हेल्प ऑफ एग्जांपल कि एवरी पॉलिनोमियल फंक्शन इज ए कंटिन्यूअस फंक्शन, सो दैट इज कंटिन्यूअस। इट मींस लिमिट x is tending to c f x equal to fc, hence every polynomial function is a continuous function. So okay, now we shall discuss one more example or one more theorem. We can treat these examples as a theorems, or we can use directly in the question. Suppose you will get any modulus function in any question, you can directly write it that function is continuous, because we know that modulus function is always continuous function, polynomial function is always continuous function. One third one example. Third, every rational function is a continuous function. So before discussing that example, first I would like to discuss some properties of continuity of the function, that is called the algebra of functions. So we shall discuss algebra of continuity functions. Algebra of continuous functions. If f and g are continuous functions and x equal to a, then number 1, f plus g is also continuous at x equal to a. Second, f minus g. Third, f into g. Fourth, f by g at x equal to a, but don't forget g of a not equal to g, क्योंकि उस पॉइंट पर फंक्शन g की वैल्यू 0 नहीं होनी चाहिए, अदरवाइज ये एग्जिस्ट नहीं कर रहा है। और अलजेब्रा में आप जानते हो, अलजेब्रा में लिमिट भी आपको बताया था, अलजेब्रा प्लस minus multiplication and division. If a function is continuous, f and g are continuous, separate at point A, then their sum, their difference, their multiplication and their division are also a continuous function at that point. This is the algebra of continuous. Now we shall discuss two more examples or two more theorems. First one is that every rational function, all of you know very well. Example 3, every rational function is continuous. Every rational function is continuous. Okay students, so in this video we shall discuss only that things. In my next video we shall discuss every rational function is continuous. One more example on dependent function, and composite functions are also continuous. So in my next video we shall discuss rational function related to that examples, and one more composite functions are also continuous. कंपोजिट फंक्शन जो कि मैंने क्लास 12th में फर्स्ट चैप्टर में डिस्कस किया था, उसको मैं फिर से एक बार डिस्कस करूँगा। तो तब तक के लिए सभी को बहुत बहुत धन्यवाद। ओके।